Good morning students. In previous class we have learned shapes of orbitals. So now we will discuss about a new topic, that is energies of orbitals. First of all we will see energies of orbitals for hydrogen atom. For hydrogen atom. In a hydrogen atom, so one nucleus is there, that means in nucleus one proton is there and one electron is revolve around the nucleus. So this is the information about hydrogen atom. So now we will discuss about energies of orbitals in hydrogen atom. So generally hydrogen containing the one proton in the nucleus and one electron revolve around the nucleus. So due to here which only one attraction force is there, that is between nucleus of one proton as well as one electron. So we will see here orbitals energies is also only depending upon the principal quantum number. So this is applicable for only hydrogen atom because one electron system. Hydrogen is a one electron system. That's why orbitals energies is only depending upon the n value, that is principal quantum number value. So here we will see increasing order of orbitals energies. So 1s is less than 2s is exactly equal to 2p. So this is applicable for only one electron system, that is hydrogen atom. If more than, that means multi-electron system, so these two orbitals having different energies because principal quantum number is same but azimuthal quantum number is different. Okay, but for hydrogen atom there is no repulsions between the electron and electron, only attractions between the nucleus and electrons is there. That's why here azimuthal quantum, if azimuthal quantum number is different in hydrogen atom, so both orbitals having same energy, but increasing of principal quantum number, that is 1s, 2s, 3s, like this energies, orbitals energies is increases. So here what happened, 2s and 2p both are having the same energy, that's why these orbitals are called degenerated orbitals. Already we know that in quantum numbers, degenerated orbitals. Here is also 3s, 3p and 3d. So these are also degenerated orbitals. So define the degenerated orbitals. If orbitals having the same energy, those orbitals are called degenerated orbitals. Here 2s and 2p orbitals both are degenerated orbitals. But it is applicable for only one electron system, that is hydrogen atom. Because in hydrogen atom only attraction between the nucleus and electron is there, that's why orbitals energies in a hydrogen atom is depending upon only principal quantum number but not depending upon the azimuthal quantum number. And here for hydrogen atom, 1s orbital is a ground state. And remaining orbitals having excited state orbitals. If the electron is present 2s or 2s, 2p or any one of the orbital, we called that electron is excited. If the electron is present in 1s orbital, we called that electron is present in ground state. So here one of the diagram is also present for hydrogen atom. You will see it is a relative energies. If here, so each line is represent one of the orbital. Here 1s orbital. If here another energy level, that is 2s orbital, only one orbital, and 2p. So these are 2p orbitals, but both are having same energy. Here 3s orbital, 1 2 3 orbitals, that is 3p orbitals, and 1 2 3 4 5, here 5 3d orbitals. So all same shell having a different azimuthal quantum numbers but having same energies. So this is applicable for hydrogen atom only. Here 4s 1 2 3 is a 4p, 1 2 3 4 5, it is a 4d, 1 2 3 4 5 6 7, 4f orbitals. What is the reason? If azimuthal quantum number is different but having a same energy, what is the reason here? Only one attraction forces between the nucleus and electron is there. Only one attraction force is there. That's why if the azimuthal quantum number is different but having a same energies of that orbitals. Here 2s and 2p. So this is applicable for hydrogen like atoms or hydrogen atom. One electron system. If multi-electron system, these two orbitals having also different energies. We will see here for multi-electron system. So this is the information. So all this information about hydrogen atom. Hydrogen atom means one electron system. It is applicable for one electron system. Only attraction forces is there between the nucleus and electron. For multi-electron system, that means more than hydrogen atom. In multi-electron system, for example, it is a nucleus. So these are the shells. Okay, here in first shell having a 2 electrons. For example, here another electron is also there. This is another electron in second shell. Okay, so here attraction between the electrons is there, attraction forces is there between the nucleus and electron, as well as repulsion forces also there. Here repulsion forces also there between the electron and electron. So these electrons, so near by the nucleus, these electrons is called core electrons. Core electrons, and the valency, so this electron is called valency electron or valence electron. Valence electron, and nearby the nucleus the electrons are called core electrons. So here two forces are there, which are, one is attraction forces. So one is attraction forces and second one is repulsion forces. So both forces are exist. So which for multi-electronic system. Multi-electronic atoms. So multi-electronic atoms, that means for example lithium, you take a lithium. So how much so 3 electrons are there, in 2 electrons is first shell and another shell 1 electron is there. For multi-electronic system, 2 forces are there, which are attraction forces between the nucleus and electron, and repulsion forces also there between the valence electron and core electron. Core electron is also called inner electrons. and valence electron is also called outer electrons. We called inner electrons and outer electrons. For example, we see the multi-electron system, the energy levels here for multi-electronic system, relative energies. Okay, so this is the, so only one line is there, that is 1s, like this. Okay, 1s orbital energy, and next here 2s, here 2s, and the 2p orbitals also having different energies. So in one electron system or for hydrogen atom, both are same. 1, 2, 3. 2p orbital having a 3 orbitals. 2px, 2py, 2pz. So, but the different energies are different for 2s and 2p orbitals, because here two forces is there, which are, one is attraction forces and one is repulsion forces for multi-electronic system or multi-electron atoms. And next we take a 3s orbital and the 3p orbital. 1, 2, 3. It is a 3p orbital. Next one is 4s orbital. Next one is 3d. 1, 2, 3, 4, 5 is a 3d orbitals. So all orbitals, so here principal quantum number is same, but azimuthal quantum number is different. So that's why energy is also different. Because why? Because in multi-electronic system orbitals energies is different. So two forces are there, one is attraction, one is repulsions are there. But for hydrogen atom only one forces is there, that is attraction forces. Only one attraction forces is there. Only attraction force is there. That's why principal quantum number is same, but the azimuthal quantum number is different, but having a same energy. 2p, 3s, 3p, 3d. For multi-electronic atoms, orbitals energies is depends upon n plus L values. Okay, in multi-electronic atoms, orbitals energies is depend upon the n plus L values. For hydrogen atom only depending upon the n value. Orbitals energy only depends upon the n value, but multi-electronic atoms orbitals energies is depends upon the n plus L values. Okay, if n plus L value is high, orbital energy is also high. If n plus L value is high, so that orbital energy is also high. For example, you comparing the 1s, 2s and the 3s like this, okay, or 2p. So here n plus L value, for example here 1s, you calculated the n plus L value. So 1 is represent n value and s is represent L value. So for s orbital L value is 0. Okay, so you calculated the n value is 1. So n plus L is nothing but 1 plus 0. How much is a 1? So for 1s orbital, n plus L value is 1. For 2s orbital, n plus, so 2 is represent n value, L is For s orbital, L is equal to always 0. So that's why n plus L value for 2s orbital is 2. And next 2p orbitals. If n value is a 2 and the L value for p orbital is 1, so here 3. So comparing the 1s, 2s, 2p orbitals, the orbital's energy, in which orbital is high energy? So if the orbitals having a high n plus L value, that orbital having high energy. So comparing 1s is a 1, n plus L value is 1, 2s is 2, 2p is 3. So here 2p orbital having a most or high n plus L value. So that's why the energy is also, orbital energy is also for 2p orbital is high. So here is also clearly mentioned that it is a 1s orbital, here 2s orbital, here 2p orbitals. So energy, comparing the orbital energies. So here 1s orbital is a low energy. Comparing the 1s orbital, 2s is a high. Comparing the 2s, 2p is high. So like this 3s, 3p, 4s, 3d like this. So one point is, what is the, if n plus L value is high, that orbital energy is also high. Sometimes, here very important another point, sometimes both orbital having a same n plus L value. Both orbital having a same n plus n value. At that situation we considered, so which orbital having high principal quantum number, that orbital energy is high. For example, here comparing the 4s and 3p orbitals. First of all, we find the n plus L value. So we'll already known that it is a n value, it is a s value means L value. L value for orbital is 0. So that's why is a n plus L for the s value, s orbital is 0. So how much the n plus L value? Finally 4. Next, here 3p orbitals. 3p orbital n value is a 3 and p value or L value for p orbital is 1. So how much? So here is also, so 4s orbital having a same n plus L value, 3p orbital having a same n plus L value. So at these situations we consider only high principal quantum number. So which orbital having a high principal quantum number, that orbital energy is high. So that's why 4s orbital having high energy comparing with the 3p orbitals. So already we know that here in diagram. So comparing with the 3p orbitals, 4s orbital having high energy. So this second point is very important. Okay. So whenever in multi-electron system, orbital energies is depending upon the two values which are principal quantum number and azimuthal quantum number. And in this n plus L value is high, that orbital's energy is high. So here we can simply say that 1s orbital comparing the energies, 1s orbitals. So 2s orbital energies are increases. So 1s orbital is low and next 2s orbital, next 2p orbitals, next 3s and 3p and 4s, 3d orbitals. Here also you comparing the 4s and 3d. For example, here 4s and 3d. You calculated the n plus L values. Here 4 plus s value is a 0. So how much the n plus L value is 4 and 3d. Here n value is a 3. L value for d orbital is 2. So how much? 3 plus 2 is a 5. So n plus L value. So which is more here? 3D is more having n plus L value. That's why orbital energy is high. So here, so 4s, the energies of 3D orbital is high comparing with the 4s orbital. So how can we find it? Which orbital having a more energy? That is n plus L value. Comparing the n plus L value, we find it that orbitals having high energy. And second one is also, if n plus L values are same, we can find it the more principal quantum number that orbital having high energy. Comparing with 4s and 3p, 4s is a high. So both orbitals having a same n plus L value, but 4s orbital, because principal quantum number is high, that's why 4s orbital having a high energy comparing than 3p orbitals. And here very important point is screening effect or shielding effect. Shielding or screening effect. We know that in multi-electron atoms, so both forces are there, which is one is attraction forces, second one is repulsion forces. For example here, so multi-electron system. So here is also electron is there, and here is also in core electrons, means inner electrons is there and outer electron, it is a nucleus. So two attraction forces are there. So two forces are there. One is attraction forces, second one is repulsion forces between the electron. Two forces are there in multi-electron atoms. So here, due to the presence of inner electrons, the forces, that means attraction forces by the nucleus on valency electron is decreases, because these electrons are shielded. These electrons are shield the nucleus power on valence electron. So this effect is called shielding effect or screening effect. So definition, once again definition: outer shell electrons are shielded by inner shell electrons is called shielding effect. So due to the presence of inner shell electrons, so these nucleus effect on the valency electrons is lowered, because inner core or inner electrons are shield the nucleus power on valency electron. So this effect is called shielding effect. And this shielding effect is depending upon the two parameters. One is shell and the second one is shape of the orbitals. Shape of the orbitals. Once again repeated, what is the screening effect? Outer shell electrons are shielded by inner shell electrons. Outer shell electrons are shielded by inner shell electrons is called shielding effect. And this shielding effect is depending upon the two parameters. One is shell and the second one is shape of the orbitals. So from this we can conclude that s orbital, the electrons present in s orbitals are more shielded. So shielding power is s orbital having a more shielding effect. If the electrons is present in s orbital, that electrons are more shield the nucleus power. Next p orbital, next d orbital, and finally f orbital. Because why? Because here s orbital having a more shielding, because s orbital having spherical shape. S orbital having spherical shape, that's why if the electron is present in s orbital, if the electrons are present in s orbital, that electrons more shield the nucleus power on valency electron. The question is rising here, the shielding effect. So which of the following orbital having a more shield? Okay, if the electrons are present in s orbital having more shielding, this is a decreasing order of shielding effect. It is decreasing order of shielding effect. And next one is effective nucleus charge. Effective nuclear charge. It is represented by ZeF. Okay. Effective nuclear charge is nothing but the net positive charge experienced by the outer electrons is called effective nuclear charge. Okay, so what is the definition? The net positive charge. I will send notes, so don't worry. The net positive charge. The net positive charge experienced by the outer electrons is called effective nuclear charge. And this effective nuclear charge is directly proportional to atomic number. And this effective nuclear charge is inversely proportional to azimuthal quantum number or orbital quantum number, that is L. So here atomic number is a Z. So these 2 points are very, very important. So effective nuclear charge is directly proportional to atomic number, that is Z, and effective nuclear charge is inversely proportional to 1 by L. So once again repeated, all are okay. So orbitals energies. So here orbitals energies for one electron system and orbitals energies for multi-electron system. Orbitals energies for hydrogen atom only depends on principal quantum number. What is the reason? Only attraction forces between the nucleus and electrons is there. So that's why orbitals energies is depends only on principal quantum number, that is n value only. For multi-electron system, what is the two forces are there? So one is attraction forces between the nucleus and electron, and repulsion forces between inner electrons and outer electrons. Outer electrons are called valence electrons, inner electrons are called core electrons. So here two forces, one is attraction, one is repulsions are there. That's why the orbitals energies is depending upon the n value as well as L values. So both values depends. Next here high n plus L value, that orbital having high energy. Comparing the 1s, 2s, 2p, 2p is a high energy because high n plus L value. For example, n plus L value is same. At that situations we consider principal quantum number. Which orbital having high principal quantum number, that orbital's energy is high. For example, 4s and 3p. Which one is 4s orbital having a high energy? Because 4 is represent the high principal quantum number. Next, shielding effect. So due to the presence of inner shell electrons, the nucleus power on outer shell electron is decreases. That effect is called shielding effect. The decreasing order of shielding effect is like this. S orbital is greater than p orbital is greater than d orbital is greater than f. So why? Because s orbital having a more shielding because it is a spherical shape. Next, effective nuclear charge. That is means the net positive charge experienced by the outer electron is called effective nuclear charge. Effective nuclear charge is directly proportional to atomic number and it is inversely proportional to azimuthal quantum number.